We have another question related to projectile motion. It says prove that for angles of projection which exceeds or fall short of 45 degrees by equal amounts, the ranges are equal. Let's understand the question first. It says that for a projectile, suppose here are my axes, and we know that we get a maximum range if a projectile is fired at an angle 45 degrees. Now question says that for all the other ranges, suppose I choose another range 35 degrees. The angle is 35 degrees. This 35 degrees is actually 45 minus 10. I reduce the angle 45 by 10. So 45 minus 10 equals 35 degrees. So question says that the range I have got for the angle 35, I should get the same range for another angle. And this angle is 55 degrees. So if I fire a projectile at 35 degrees, it will arrive at the same location. If I fire a projectile at the angle 55 degrees, it will still land at the same place. So 55 is actually 45 degrees plus 10 degrees. So in the first time I actually subtract 10. So I reduced 45 to 35 degrees, and in the second step I actually increase the 45 degrees by 10. So the increase or decrease is equal. The only difference is in the first step the angle is decreasing, in the second step it is increasing. But decrease or increase is same, right? It's 10 degrees decrease, and here it's 10 degree increase. So it is true for any other angle. For example, you can decrease by 20 degrees and increase by 20 degrees. These two projectiles will always land at the same location, whatever is the location, but they will always land at the same location. So our job is to prove that this is actually the case using our equations. For example, I have written the expression for the range here, which we can use it. So let's try to solve it. So I have divided my screen into two sections. So I will do the increase related calculations here and decreasing angle related calculations in this section. So we know that in the increasing section we can replace theta with 45 degrees plus x. X is any angle you want, because in the increase section we always add a certain amount of angle, and in the decrease we can substitute theta is equal to 45 minus x, because in the decreasing section the amount is same, but the only difference is we subtract it, and in the increase section we add it to the angle. So let's calculate the range for both of these angles. So I can call the left one as the increase, or we can give it a name R1, or we can give it a name R2 just to identify, but I will write the expression v squared sine of, now I will replace theta with 45 plus x. X is any angle you want. So 2 into theta will become 45 plus x over g. Similarly, on the right section, which is for the decreasing angle, I will write v squared sine of 2 into, I am replacing theta with 45 minus x divided by g. So we will just keep going this way to see if they become equal at the very end. If they become equal, we will prove it that for angles of projection which exceed or fall short of 45 degrees, the ranges are equal. Now here I can simplify the expression inside the sine. So let's simplify it. V squared sine of, so if I multiply 2 with 45 and 2 will also be multiplied with x as we know from the basic algebra. So it will become 90 plus 2x over g, and here it will become v squared sine of 90 minus 2x over g. Now we need to solve this expression, because without solving this expression we can't get anything useful. If you see, it is sine of one angle plus another angle. Here it's sine of one angle minus another angle. So we need to find a suitable identity. I hope you are familiar with trigonometric identities, where you can find a lot of formulas like this. If you get a sine of alpha plus beta, so a trigonometric identity says it is equal to sine of alpha cosine of beta plus cosine of alpha sine of beta. In the negative section, it is sine of alpha minus beta, and it is equal to sine of alpha cosine of beta minus cosine of alpha sine of beta. So these two formulas will help us to solve the expressions containing the sine of theta in both cases, because without simplifying we can't get anything. Let's use these formulas to the ranges, to the respective ranges we have. So if I start from the left side, which is for the increasing angles, it will become v squared. So I will write the expression in the brackets. So if I am using sine alpha plus beta, so instead I can write sine of 90 cosine of 2x plus cosine of 90 sine of 2x divided by g. I can do the same on the right side, so it will become v squared, it's sine of 90. The only difference from the left side is the positive, is the negative sign. So sine of 90 cosine of 2x minus cosine of 90 sine of 2x. over G. So now let's analyze the situation. I have sine of 90 and cosine of 90, and let's see their values. I use my calculator and it says the sine of 90 is 1. So sine of 90 is 1, cosine of 90 is 0. And here it's 1, cosine of 90 is 0. So it can simplify my expression. I know that anything which is multiplied with 0 becomes 0. So this whole expression will become 0, and same is the case on the right side. This whole expression will become 0 because sine of 90 is 1, so I will get only cosine of 2x. So let's rewrite this expression, the reduced form of these expressions. So it will become v squared cosine of 2x, and of course this v squared will also be multiplied with 0 and it will end up with 0, and then I can divide by g, and I can write the expression on the right side. It's v squared cosine of 2x because sine 90 is 1 divided by g, and when this v squared is multiplied to the second term, which is 0, it will become 0, so the right side will just vanish. Now just see these two expressions. These are actually these expressions are from the two different situations. On the left side we started with theta 45 plus x was any angle, and on the right side we started with 45 minus x. So these were two different situations. We on the right side we reduce the angle by an amount x, on the left side we increase the angle by an amount x. So on the right side and left side there is a decrease and increase, but in equal amounts, like the condition which was given in the question. And now if we see the expressions, they are same. So we have just proved that for angles of projection which exceed or fall short of 45 by equal amounts, the ranges are equal. Let's use this animation to verify the results of the question we proved. I have the cannon here, so I will just fire a cannonball at the angle 45 degrees and I will get the maximum range. So now according to the question, I will decrease the angle by certain amount and then I will increase it later by the same amount, but I will increase it. So let's choose 10 degrees. 45 minus 10 is 35 degrees. So I fire a cannonball at 35 degrees and it has hit the ground at this place. Now I will increase the angle by 10 degrees from 45 degrees. So 45 degrees plus 10 is 55. And I fire the cannon and let's see if the cannonball hits at the same place. Yes, it has landed at the same place. So it means we have proved it rightly. So here is a question. My question is, does it matter if you choose any of these two angles? For example, you want to hit something at this place, so you have the choice. You can either choose 35 degrees or you can choose 55 degrees. My question is it the same? I can give you a clue. We have studied 3 parameters related to projectile motion. The time of flight, the range of course, which is equal in this case, and the maximum height. So do you think it's same, or is there something different between these two choices? Although ranges are same, but maybe something else is different, and it may matter in your case. Just think about it.